Hello everybody, welcome to this tutorial on learning how to simulate consumer market, and we are going to do this using agent-based modeling in AnyLogic PLE. So there are two great things about this tutorial. The first thing, it is for complete beginners. That means you don't need to have any prior experience or knowledge of AnyLogic. I will teach you all the necessary steps along the way. And the second great thing is this is a complete tutorial. That means that by the end of this 2.5-hour long video, you will be able to simulate consumer markets and you will be able to tailor it according to your needs, and you can do different experiments as per your requirements in this simulation. So without further ado, let's move to the real task of simulating consumer market. In this video, we are going to discuss agent-based modeling, and we are going to apply in a marketing simulation study. And the topics that are covered in this video is the problem definition, and then we'll have a small intro to AnyLogic. So the first thing is the disclaimer. It mentions the AnyLogic PLE edition used for the development of the models used in this tutorial, and then there are books from which the material has been borrowed for making these tutorials. Okay, so the problem scenario. So first the background. So imagine a university that has a student population of 5,000 students, and a student startup of this university, let's call it Hydra Smart, is trying to launch a smart water bottle. And this bottle is very high tech, it tracks hydration, it reminds to drink, and even syncs with the phone. So the startup company, is wondering how its product will be adopted by the students. So these 5,000 students are considered as the potential users of this bottle, and the company has launched an ad campaign, and these ads, uh, historically, the company thinks that this ads will have an ad effectiveness the effectiveness of around 1%. So all students are potentially, at the start of the problem, they are potential users, and with the advertisements having a 1% effectiveness ratio, these advertisements will convert the potential users to users. So graphically, potential users, when they come across the ads which has some ad effectiveness, they will become users. In addition to these ad campaigns, there is another thing as a word of mouth. Each user, when it interacts with the peers, it has the probability that that student will try to convince others to adopt the same bottle. So another aspect in this, which will be very important for the adoption of this product into the university students, will be the word of mouth. So, and let's say that each student contacts at least one student per day, and we can define this contact as contact rate. And during this contact, the user might try to convince the potential user to use this bottle. So, and depending upon the way the potential user is convinced, they might even adopt using the water bottle. So we will have another thing called as adoption fraction. This would be the fraction of the students who would be convinced to adopt the this product. So, one thing is advertisement, second is the word of mouth. Now let's also consider another aspect of this product, and that is the product life cycle. So let's say the product has a life of 6 months. So after expiry after 6 months, the users who are using this product, they will again go back to a potential user state, and in that state they would be seeking the replacements. Again, graphically, users, when the product life ends, they will become potential users. Another very critical aspect to a product adoption is the product delivery time. So obviously, like all the products in this world, the delivery of this smart bottle will take some time, and some of the students would be happily, would happily wait for this product to be delivered, and others might not be much, others might lose their patience, and then they might, kind of they cancel their idea of purchasing the product. So this is kind of a brief scenario of this problem. The challenge here for the Hydra Smart is to understand how widely and how fast their product will be adopted across the student population. The startup, they needs to basically predict the product adoption curve, and they will be, and we have to, in order to develop this product adoption curve, we have to balance ads, word of mouth, product life cycle, and delivery days. So in all of these things mentioned here, uh, balancing word of mouth is basically, it can't be balanced, and other things like advertisements, life cycle, and delivery days, they are some things uh, that can be controlled by the company. And by varying these parameters, the company might want to predict how the product will be adopted by the users. So let's uh, this is the whole, setting of the problem. Now, before we start modeling in AnyLogic, let's have a small brief tour of AnyLogic. So in the description, that is also mentioned, so in the link that is also mentioned in the description, you have to download this personal and learning edition, and then you have to install it like the other software. And once you are done, you will open the AnyLogic PLE, and then you will come across a window like this. Now, this is the preface. This is the this is the interface that you are going to see when you install AnyLogic. So if you focus on the top ribbon, and which I have also encircled it, so there are like many things here: file, edit, view, and other menus. So out of these menus, the one that is encircled now, it is used for making a new model. So since we are making this model, so you will click on this menu, and when you will click it, another another menu opens up, and then there is the option of making a new model by clicking on the model, or by just pressing Control N. So when you press Control N, another window pops up, and here are like four things here: model name, location, Java package, and the model time units. So model name is the, let's call it market model phase 1, and this name should be written without spaces, because we are right now, first we will do the phase 1 and then phase 2 and so on for this complete example. The second thing is the location. You can browse and save the model in the location of your choice. Third is the Java package, which is automatically updated by the AnyLogic, so you don't need to worry about this thing. And the last thing is the model time. So in this marketing simulation study, we will be measuring time in days, so you can just select days here. And remember that units are really important for the simulation. So once you are done with these three things, you click finish, and then you will have this sort of a window in which your new model like market phase one has been created. And then so there are some other sub menus here: main, simulation, time, configuration, and so on. So this thing, there are like if you look at the left hand side, there are two things here: projects and palette. And on the right hand side, in the under in the green circle, you can see the properties. So this is the left one is the project and palette, and the on the right is the properties. So let's first see what is project. So when you make a new model, in the new model, in every model there are like two things available to you. There are two menus: one is the project and one is the palette. So in the project, you at the top, it's a it's like a tree like structure. So we have the model market phase one, and and right below the market phase one there is a main. So our model has one main edge agent, and all the model will be placed here, and we will place our agents here, and then we will uh, modify the agents in their own respective diagrams. For right now, we just take it like this: that main is the main window where we are going to make the model or the blueprint of the model. So this is main, and this thing here, open tab, is the diagram where we are going to place different components of our simulation. So uh, the second thing on the left hand side is the palette. So the palette is basically the libraries that are available to you. So there are like many libraries here, and uh, obviously in the beginning you won't be able to remember, you won't be able to identify them by just looking at the icons. So if you just hover your mouse over any icon, you will the name of all these libraries will open. For instance, like process modeling, material handling library, and pedestrian library. So there are like many useful libraries in AnyLogic. So let's say we select process modeling library. If we select this library, then it will open the components that are available to us. And you see there are like many things here, which obviously you would which might which obviously by the end of this tutorial you would be able to recognize many of these things. So let's see, we have here a source. So if I click on the source here, so this is source, and if I just click on the source and drag it to the I can just drag it to the main window. So if I click the source and drag it to the main, I'll have something like this. So I have dragged source from that process modeling library to the main diagram. Now if I click on this source, then on the right hand side this is the properties section. Now this properties section, it is used to define the properties of the item that you have dragged into the main. So right now I have dragged main source here. So on the right hand side we have the properties of different components. Are there different type of properties? Again, when we will do it, you will understand how it's done, what does that mean. Finally, there is the another thing here, and that there are like two more options of interest. Right now there are so many options, but right now I will focus on this thing which you can see on the top. and this is called as a build model. The shortcut key is F7. So when you are like connecting the components, if you press F7 or you click on this icon, your model will be built. And the good thing is, if there are like some errors here, so you will also have a, at the bottom there is a console will open, which will tell you there are some errors here, and it will also tell you the type of errors. And right beside the model built, there is another play button, which is called as the which is used for running the model. So this is a brief virtual intro of the AnyLogic. The point is that after finishing this video, you should go to that website. The link has been given on the in the description. That is AnyLogic PA and AnyLogic website, and from there download the PLE edition. And in the next video, we are going to actually build the model, build our simulation market simulation model. So uh, that's all for this lecture. Thank you very much. Welcome to part 2 of agent based modeling, and we are doing it for marketing simulation study. So in this part we are going to make agent population. And in the if you remember from the last example, there were like 5,000 students in the university. So in this part we are going to make the population of students for our marketing simulation. So as always, the first thing is about the disclaimer about these videos. So let's move to the part 1, and that is creating the population of students for for our marketing simulation. Okay, so let's build your first simulation. And now in this slide I will show you the steps, and then we will move on towards the AnyLogic, and then I'll show you how it is actually done in AnyLogic. So the things that we are doing in this part of the in this video is basically we will be creating a model in AnyLogic, and I hope that you would have already made the model using the name and of your choice and the time unit in days, which we discussed in the last video. So now in this video we will create an agent population. The consumers, basically, as we discussed earlier, there are 5,000 students, and all the students are they can be the consumers of our product. So these consumers, or the 5,000 consumers or students, they all are potential users, and when they come across ad which has an ad effectiveness of 1%, some of them will become the user of the product. So from potential user, they will become user. So here we will define the agent population of the students, and then we will define some attributes of this population like size, the graphics, and then we will add ad effectiveness as a parameter of the population, and then we will define its environment, and finally we will run the simulation, and our expected outlook will look like this. But don't worry, we will just see how it is actually done in AnyLogic. So we move towards AnyLogic. So in AnyLogic, I have already opened a file named market phase 1, and the units are days. So and furthermore, I have already copied these steps which we discussed in our PowerPoint slides. I have already discussed I've already mentioned the steps here. So the first thing is we to create a model. It's already done here, and now we are going to create the here the agent population. So right now we are in the project phase. So let me just open here and open the palette uh, tab here. It was closed before. So the project is here, and the project, as we discussed, it's a tree like structure. We are right now in our main agent diagram. This is the diagram where all the agents in our program will exist. So first thing, go in the palette library, and here there are many libraries. So we will go towards this red agent library. You click the agent library, and the menu, the items of the agent library will open. So from here, select this agent and then drag it in the diagram main. When you drag it, and you are asked the question that what do you want to do, because you want to create a population of agents. So click here. So now this is the, it is creating the population of your agents. So we will call this population as consumer, and remember this consumer, and the consumers, agent name population consumers already, it already it automatically, it is written automatically in AnyLogic. So these consumers, they represent our students. So press next, and then there is like the graphics. We will use the two-dimensional, and this is the default graphic. Now press next, and then we can add the parameters here. So the parameter for our agent is add effectiveness. So click add new, right here, add effectiveness. Remember, no spaces here. The type is double, and we discussed earlier that the add effectiveness is 1%, so we will write here 0.01. Then press next. It will ask you how many, about the size of the population. Because we have 5,000 students, we will type here 5,000. So there is no more option left, so just click finish, and then you will see that in your main diagram a consumer population, it has been made here. So I'll just make the properties window bigger. Now uh, right now we are in the main diagram of the model, and if you look in the properties and then in the space and network, you will see it's mentioned here that agent in this space are consumers and their layout is random. So there are multiple options here. We will choose, they can be arranged, I mean how the agents are placed in our simulation model. I'll choose the random here, and I'll just choose the default values of 500 500. So this is basically the space 500 by 500 in which our agents will exist. Now once this thing is done, I'll just move this age consumers, and I will move it away from this blue lines, because these blue x and y axis, it is the place where our agents will exist. Now just to give you an idea, that if I double click on the consumers here, you know a consumer tab opens up, if you can see here. So here this is main, and this is consumer, and this consumer tab in this diagram, there is, and you can see the top, the consumer graphic, and then there's a parameter add effectiveness. And if you just on the right hand side are the properties. Again, in the space and network, if you click, you see the space type is, you can just, again, you can do it random, and then or you can choose user defined, whatever, because we have already done it in the main, so it doesn't make a difference here. So this is our the first step, that we have created an agent in the main, and where we double click it, we can see that the consumer diagram, and in which there is the parameter which we just add effectiveness. So now we go back to the main, and if we press F7 or this button, the model is built, and it is, you can see that in the bottom, it is written built completely in time 0.302 seconds, and without any errors. So we are good to go. So let's run the simulation, and for that, press the screen button, and when you press it, you will see that your model will start running. So if I just click anywhere, and just I can drag it. So I'm just dragging it here. Now this is my simulation. So at the bottom, if you can see, there are like multiple things. This is for pausing the simulation, this is for stopping it, this is for reducing the speed, and this is for increasing the speed. Right now it is moving at this simulation is going on at the speed uh, of uh, at the normal speed. We can increase the speed, we can double it, we can make it 5 times. Or the button on the right hand side, it is the button used for making to run simulation as fast as possible. So I'll just click here, and you see now that it is running as fast as possible. And here you can see it is written, this is finished, the simulation is finished. So this is 500 by 500 space in which we have made a population of age of 5,000 agents. And these 5,000 agents, or this is basically agents population, which are the consumers or the students in our example. So this is the phase one of making the agent based model for the marketing simulation. So in the next phase we will define the behavior of this student population. So that's all for this video. That's all for this video. Thank you very much. In this video, we are going to discuss uh, agent-based modeling for marketing simulation. This is part 3. In our previous part, we defined the agents population, and now in this video, we are going to define the behavior of this population. So the first thing first, the disclaimer, the software and the books used for making these tutorials. So the objective of this main objective of this video is defining agents behavior. So just to clarify a few things, that in our original problem setting we had 5,000 students in the university, and those 5,000 students we discussed, these all students are potential users. So when they come across advertisements, they become users. And the effectiveness of these advertisements is like 1%. We defined it in our last video. So basically, uh, in AnyLogic we are defining the population of the students as agents. Okay, so how to define the behavior? There is a very interesting tool in AnyLogic called as a state charts. The state charts, they are used for defining the behavior of the agents. And if you go to the palette window, and then we have a whole library of that has tools related to state charts. So the state charts have many options, and we'll go through them one in this video. Some are like states and transitions. So in our problem, we have defined two states. So far, we have defined two states. The first state is a potential user. By that we mean the 5,000 students, they all are potential user. And once they come across ads 1% of with 1% effectiveness, some of them will become user. So uh, in the palette view, this yellow box is basically, it represents the state charts. And then there are like there are some tools in it. The first one is the entry point, that how the agent enters into a state. Then there's a state, then there is a transition, final state. So we will use like 2-3 things here: entry point, state, and transitions. So let's do it. But before switching to AnyLogic, I'll just show you the steps. So the steps we have for defining a state from potential user to users. So we will open the consumer diagram by double clicking the main, and then we will, because the state chart starts with an entry point, so first thing we will drag an entry point, and then we will drag a state, and then we will make sure that the entry point and state are properly done. So this is, if it's properly done, then this connection becomes, kind of light blue color. So sky blue color. So we make sure that it is properly done, and then we modify the properties of the state. For instance, the first state, when our simulation starts, all the students are potential users. So we will, in order to identify, in order to differentiate between the potential users and users, we will use some colors here. So the potential users, we can make those agents as blue, and then we will uh, use some code here, and we'll write that when the user, when the agents are in a potential user state, they should be in blue color. And then we will make another state, which would be the user state, and we will do the same procedure here. And in order to differentiate from potential user to user, we will make the user in the user agents in green color. And then we will add a transition from potential user to user, and we will record that transition, the basically the adds, and which has some add effectiveness. And then we will define the transition rate, and then we will uh, and one thing here, that when we define a rate, it is basically drawn from an exponential distribution. So don't worry, it might sound a bit overwhelming at the moment, but let's move to the AnyLogic, and I'll show you how it is done how it is done step by step. Okay, so here is AnyLogic. I've already opened this AnyLogic here, and all the instructions that you just saw on the slides, they are already pasted here. So let's start it one by one. So uh, it says that open the main diagram. Okay, just it says open the main diagram and then double click on the consumer. So here, this is our consumer, and if I just double click it, so then what happens is that, if you can have a look at the top, that a consumer diagram opens. Okay, so we have to do these steps in this consumer diagram, because we are defining the agent's behavior, and consumer is our agent. So I'll just copy this image in the consumer diagram, so that it is uh, visible to you, that what are the steps that we are going to do. So we have now we are in the consumer diagram. Now we'll go to the palette section, and in the palette section, if you can see, if you can follow my mouse, then this red thing, it is basically this yellow rectangle rectangular type box is basically for the state charts. So I'll just click state charts, and then we have the options here. So the first thing, we are told that uh, drag this entry point. So this is the entry point, and there should be exactly one entry point. So I'll just drag this entry point and put it somewhere in our diagram. Okay, then the next step is drag the state. This yellow is state, so I'll just, let's say, I will drag it and bring it in a diagram. And if I bring it close to that entry point, then you will see that it will connect with it. Okay, so but we have to make sure that it is properly connected. So I'll show you again. If I just delete it and then again drag this state point, so this thing has to, now you see the dot connecting has now kind of, uh, has changed the color. It's I think it's cyan color. Now it is connected. So we have dragged a state and connected it to the state chart. Our connection is proper in the cyan color. Now we will select the state, and we will, when we select it, and we have to modify it. And the modification is, if I click on the state, then on the right hand side we have the properties of the state. So we use the properties. So the properties are, first we define potential user. So this is our first state, so we have defined it, potential user. Now second thing is color. So we are going to use, let's say, blue, or blue is I think fine for us, or let's say we use Dodger blue. Okay, so this is our uh, fill color. Now there are two options here. Entry action. Entry action means that when the agent enters this state, then what happens. So in order to differentiate between the users and the uh, potential users, we will color them. So we will write in the entry action that when the agents enter in this state, they should be of Dodger blue color. And how to do it is click on the entry button and then press Control space bar, and then if you press Control space bar, then you can write the code. So the code here is basically we are trying to change the color of this agent. So it will be shape dot body. So shape body, sorry, shape body. So this is, now the this is the option shape body. So you double click it, and then we want to uh, what we want to do here, we want to, again, we can write, we can just type it, or we can just control space type, press control space, and we will write here set fill color. So this is set fill color. So set fill color, so shape body set fill color, and we can write here the argument, and that is set fill color, and it is uh, the color was Dodger blue. So we will write here Dodger and then BLUE. So when the agents they enter in our in this state, they will be of Dodger blue color. So just press this button, and you see if there is some error, it will be shown here. Now it is built successfully, so we are good to go. Now we are going to make another state, and that will state will be of the users. So let's drag a state here, change its properties, and we call it as user. And the fill color, in the fill color we will use, let's choose this one. This is lime. Okay, let's choose the lime color. Okay, now again we will uh, in order to differentiate between potential user and user, we will make it lime color. We will make the agent of lime color. So again we will first press control space, and pressing control space, the the code assistant opens. So what we are doing is we are doing shape body, and this is shape body, double click it, and what we are doing here, again we are filling color, set fill color, and the set fill color, and okay, set fill color. Let me again see, control space, and then set fill color. This is set fill color, and we are going to make it lime. Okay, so this is our, now you see, now you see there's a potential state, and then there is a user state. We have to make a transition from potential state to user state. So what we are going to do, we are going to use this transition. So double click this transition. Now it will become a pencil shape and connect from here to this box. So if I just zoom, okay, now this is now our this is our state chart. And if you can have a look at it, that this transition we have to call it as, we will call it as add. So this is basically the add, and it is triggered by the rate, not timeout. And the rate is basically its add effectiveness. So now we have, you know, we have used. Now you have just seen here that initially it was like for timeout, it was like a clock, like here. And when we use a rate, so it has become like this, and these rates are exponentially drawn. So we are using the add effectiveness rate, and this is our complete, uh, for the moment this is our state chart. So we will just press this one and see if there are some errors. So far so good, there are no errors. And let's say let's save it. So okay, now we have also saved it. uh, there is a duplication here because whatever we try to copy in the consumer, it also gets copied in the main diagram. So because we have completed it, so I'll just delete it from here, these instructions. So we go back to the main, and now what we are going to do, we are going to run this simulation. This is phase 2. Now if we run it, so another window opens up, and now you can see here that the initially all are potential users. The majority of the agents were like Dodger Blue. So with add effectiveness of 1%, they are converting the potential users are becoming users. So if I just run it on the full scale, then what happens that after, like, if it goes after some time, all the potential users become the users. So this is our for defining the behavior of the agents. So that's all for this video. In the next video, we are going to place some charts to visualize the data. And don't forget to practice along by downloading the AnyLogic BLE from the website, and the link also mentioned in the description. So see you in the next part. Thank you very much. Welcome to part 4 of agent based modeling, and we are doing it for marketing simulation. So in our previous videos, we have created agent population. We have also defined their behavior. In this part, we are going to add some statistics, and then we will add some charts for data visualization. The first thing is the disclaimer about the material used for development of these tutorials and the software AnyLogic Personal Learning Edition. For adding the charts to visualize the data, first you need to understand that why are we doing it. So let's say we want to know, we want to count how many students have actually purchased the bottles at a given point of time. So we need some statistics for counting the number of agents in user and in the potential user state. So for counting these, the number of agents in user and potential user state, we will add some statistics to the consumer. So for that, we will open the main diagram, and then there is an icon of the consumer. If you click it, it will open the properties on the right side of the canvas. And if you go to the properties, there is add statistics button. Here you will add a statistic of type count, and because you want to count the number of potential users and number of users, so you will you will add a function of type count. And for counting, we will use a Java based code in which we will count the agent in state. That means the agents which are in potential user state, and then in user state we will count, we will add a statistic for counting the number of users. And once we have defined these two statistics, now we want to add them to chart for the visualization. And for that we will go to the analysis palette and we will add a time stack chart, and then we will add the two data items to these charts. The two items are the potential users and the users. The potential users and the users are calculated are by the statistics that we have defined earlier. So the values of these data come from again there's a Java code in which you will count the consumers which are in a potential, which are in potential user state and which are in the user state. So once we have added these items, we will make some refinements to the chart. We will update the data, number of samples, the scale, and then the vertical scale. And we will also make some refinements in the time axis, and we will also make the simulation running time. We will also adjust the simulation running time by going into the simulation main menu. So let's implement these steps in AnyLogic. So I'm going to switch to AnyLogic now. So this is marketing phase 4. I have already copied the steps that we just discussed in the PowerPoint slide. So we are in the main diagram, and if I click on this consumer icon, then on the right hand side you can see the properties of the consumer. So there is this statistics option here, and then this is the add button for the statistics. So if I click add here, then I can add statistics here. And because we discussed earlier that it's a count type of statistic, and we will add first the potential. We will try to count the number of the potential users. We'll define as n potential, and the condition for this, it comes from the by typing the code. And again, as I discussed in my previous videos, if you press control space, then you open up the code assistance mode, or you can just also just type it uh, directly into this field. So this is agent dot in state. So don't make a spelling mistake here, otherwise you will end up with some error. So we are trying to count the consumer dot which are in potential user phase. We have already defined in our previous videos the two states, potential user and the user. So press the build model button. So if there is some error here, uh, it will be visible to us because it is built successfully. So that means that it is, the statistics is okay, the syntax is okay. So you can just copy here, duplicate it. So you will open up another statistic here. So this is for the first one was the potential users, so this is for the users. So I will write it as n user. Again, it's a count function, and we are counting the agents that are in state user. So I'll just make some changes here. I'll delete the potential, and here you go. Now again press the build model, and if there is some error, you can see, you will be notified in the console. Let's say if I write here users instead of user and press this thing, then it will give you an error here that users cannot be resolved or is not a field, because we have defined the state user, not users. So I'll just correct it again, and then if I again build the model, the error will be gone. So we have defined the two statistics. Now let's add a chart to visualize these statistics. For that you have to go to the palette, and in the palette, if you hover your mouse on any icon, you can see there are the libraries in the AnyLogic. So go to the analysis, and here there are many options, and we are adding a time stack chart. So click this time stack chart and drag it to the main canvas. Okay, so now you have this statistics. Now the because the chart is selected, the right hand side is showing the properties. So let's make some changes to this chart. Now what we want to do, we want to add these statistics to the chart. So AnyLogic offers many types of plots, and we can, right now we are using that time stack chart. In the later videos we'll be using other types as well. So for now let's focus on this time stack, and this, let's modify some properties. Let's say we want to we are, there are two data items here. The first one is the user. The first one can be, let's say we call it potential user. So because this is just the title, so there is no like syntax thing here, and the thing which is important here is the data, that the value of this statistics, where will be, what will be the source of this statistic. So as mentioned here, we will count the consumer from the consumers population dot, we are trying to count the n potential we just defined here, n potential, and we will give it a dodger blue color, just consistent with our earlier theme. So build the model again and see if everything is okay. So it says that n potential is not defined. So what's wrong here? The thing wrong here is that I have misspelled potential. So if I correct it, n potential, because I just defined it. So if I build it again, you will see that the error will go away. So we have defined one statistic, we have added one statistics, one data item to this chart. Now add another. So just press add button. So this is another statistic here. So now this one we can just copy it from the above. Now we want to count the user, so I'll just name it users. Okay, and the value will be from the population of consumers, and now we want to count n number of user which we just defined, and we will give it a color, let's say lime or green. Okay, now we have added the two statistics, and we can also let's say we can, if I move the user upward or potential user, we can also move them up and down. So uh, this is the, this button, it shows how it's, how the how these items can be arranged on upside and down. Okay, so we have now potential user and user. Now we will make some refinements to the chart. So the first thing is the data update. We want to update it automatically. Then there is a display option, and sorry, recurrence time is 1 days, and the how many samples we just discussed, how many samples we want to display here. So call it let's make it for a year, so 365 samples. And then time window is basically because it for we are collecting 365 samples, we'll make the time window as time is 1 years. And then vertical scale, we'll fix it, and the value will be 0 to, let's say, 5,000. So we have now uh, made the we have now selected the time window, and then we have also fixed the uh, scale. Now there is now time access format. Here we can set the time, and let's select the time as the model time, and there are many options. We will just choose the date only, it's just fine for our purpose. So we have select the time time access format as well. So now that we have done, we can now see when how the data appears on our model. So let's see. I'll just go back to the if I just move. Okay, let's run the simulation, and you can see in the projects this the model is unsaved, so I will save it. And okay, now I will also move this chart away from our canvas so it does not interfere with our simulation. So we will run the simulation. So if we just start running a little faster, or just run it to the full space. Oh, okay, so there is something wrong here. I have not adjusted these statistics accordingly, so let me just make a small adjustment here. We can move the user upward and then the potential user downward. So if we run it again, and run it on the full scale, so here you can see that now, you see, if I run it again once more, so in a slow mode, so you will see that initially what happens here is that all are the potential users, then they start turning to the user. You see the green people appearing between the blue people. So if I just start increasing the speed, and I have made it 10 times, 25 times, 50 times, you see this, it is going on. And okay, I just missed one more thing, so I'll go back after this finished. Okay, so this is the complete simulation. Now I was just mentioning about a thing that I missed, showing you how it's done. I had already done, but I just forgot to show you. It was that you have to set the simulation running time. So if you go to the simulation main, uh, you have to look at this option. Generally it is selected as never, so you will have to select at stop at specified time, and then you have to specify the time. So because we are doing it for a year, so I have specified 365 here. So I specified it earlier and just forgot to show you during during the steps. So this is our simulation, and this shows that how the potential users are being converted to the users, and we have also specified two statistics here, and the green one is counting the number of users, and then blue is the potential users. So in this part uh, we have added the charts. So that's all for this part. In the next video we will add word of mouth in our model, and do not forget to practice along by downloading the AnyLogic PLE. So that's all for part 4. I'll see you in the next part, so stay tuned. Bye. Word of mouth is another very important aspect in product adoption process. So in this part 5 of agent based modeling for a consumer market process, we are going to add word of mouth to our model. So the first thing is the disclaimer. So what is basically word of mouth? So it is the way the people persuade others to purchase the product, and for that we have to define a parameter, and basically we will define several parameters here. So the first parameter, it is used to define how it is used to represent how people contact one another. So we will open the diagram of the consumer by double clicking the consumer icon in the main diagram. We will open another diagram of the consumer. Here from the agent palette, we'll add a parameter. We'll call it as contact rate. So let's say that each consumer, it meets one consumer makes a one contact per day, and as a result of this contact, uh, the the potential user might adopt the product, and we will represent it by another parameter, which is adoption fraction, which is 1%. So that means that when the users they interact with the potential users, so and with the contact rate of one contact per day, they might influence the potential users to adopt the product, and for that we will use adoption fraction of 1%. So it's another parameter, and it is basically describing the fraction of students who will buy the product upon contact. So now there is a very important thing is the establishing the communication between the agents, and for that we are going to define an internal transition. By that I mean that the agents which are in user state, with they will communicate to the potential users without exiting their user state. That means they will still be users, but they will communicate with the potential users. So this is shown by an internal transition, and we will call that transition contract, and that is governed by triggered by a contract rate. And when this transition occurs, they will send a random message. They'll send a message by and to the potential users, and so we'll draw another transition which will be from the potential user to the user state, and we will name it as word of mouth, or WOM. So this transition, it will be triggered by a message which is received from the user, and the message is buy. So this transition, it is guarded by the adoption fraction. So okay, and there is a code for it as well, that is random to adoption fraction. So let's try these steps in AnyLogic. So I'll move to the AnyLogic. So here I have already copied the. Okay, one thing more, if you right click your mouse, then you can drag your canvas and right, left, up, down. So for that you have to right click your mouse. So I have already added the instructions here, and it says that open the diagram of the consumer. For that we have to double click this consumer diagram. If I double click it, I'll be in the consumer diagram, and just for the sake of ease, I will copy these instructions here. Okay, so it says open the diagram of the consumer, and then from the palette, this is the agent palette, add a parameter. So this is parameter. I'll add a parameter here, and this parameter, it's called as the contact rate. So I'll call it as contact rate, and this contact rate, it's the type is basically the rate, and it is one contact per day. So units will be per day, and the default value will be 1. So now I've defined a contact rate, and you see that now I'm defining these parameters in the diagram of the agent, the consumer. So because these are kind of the attributes of the agent. So I have defined here a contact rate. Now define another parameter, that when a contact is made, the potential user might adopt the product, and this adoption will be controlled by adoption fraction. Adoption fraction. Now because it's a fraction, and it's a number, so we will use the double here, and its default value will be 0.01. Now we have defined the two parameters, contact rate and adoption fraction. So I'll just make these states a little bigger here, and so the things get visible to you. So okay. Okay, one thing more, if if I may draw a transition and it is not connecting the states, this arrow becomes red. So this red arrow shows that this is not a complete transition. So for it to be complete, it has to be connected with the appropriate states. So once it's connected with these appropriate dot signs, this shows this has been done. Okay, now we are doing an we are now going to show an internal transition. And internal transition means that a user, while still remaining in the user state, it can influence a potential user. So we will use an internal transition. So we will go to this one, the state chart menu. Here we have transitions. So if I double click on the transition, then it becomes a pencil sign, and now I want to draw a internal transition. So I have to draw it in the box, in this state box. So let's just modify it a little bit. So, and if I double click on this internal transition, it shows the points which can be used to mold it to our, as per our requirement. So I just made it like this. Now you see this transition, it is in the user state, and it is not and this transition, and just name this transition as contact. That means that this user is contacting a potential user, and it is while still remaining in its original state of user. So that's why it's an internal transition. So this transition here, this one is an external transition, because this, by using this transition, potential user is being converted to user. So this is an internal transition, and now this transition is basically, it is triggered by a rate. So we have already named it. Let's also show it here. So it's contact. So just, kind of, just for the sake of, you know, presentation, contact. Now it is triggered by the second option is triggered by, and we will call it as, so we will choose here the option of triggered by rate. So as discussed in the previous videos, that when we choose rate, originally it's timeout transition. When we choose rate, if the clock, it is replaced by a graph sort of a thing. So it is triggered by a contact rate, and the rate is already defined as 1 per day. And what are the actions, is when this transition occur, it sends a message to, it tries to influence the agents in the potential user to buy. So it will send a message to the random, to send the message to the uh, potential users to buy. So we will do it by writing a code here: send to randomly select the users, and so it randomly select the potential users, and we will send this message of buy. Okay, so now this is the send to the random buy. So now we will add here another transition, and this transition will be from potential user to the user. Now this transition, what's happening here, when the user, it is contacting a potential user and sending a message of buy, then some of the potential users, some of the, not all, some of the potential users will come to the user state. So we have shown it with a transition, and we have called it as the word of mouth. Now word of mouth uh, is converting the it is converting the users, converting the potential users from to the user state, and we are showing its name here. So it's word of mouth. Now once it's done, so it is triggered by, when this transition occurs, it is not triggered by a timeout, rather it is triggered by a message that we typed earlier to buy, and the message was buy. And there are, like, when we select buy, it asks about how it is fired. So we are firing it on a particular message, and the message is buy. And the action, this transition is guarded by, it is guarded by an adoption fraction. So we will write a code for the guard, and the guard is that random true, and this is guarded by adoption fraction, which we defined earlier as, okay, as 1%. So just build the model, see. Okay, now you see there are 3 errors here. So let's see what are those 3 errors. Okay, now it was a false message, so no errors here. So so the model is built successfully. So just to sum up the steps, we have added internal transition in the user state. through this internal transition, through this internal transition, the user, while still remaining in the user state, it is contacting the potential users and giving and sending them a message by. So we have, if I just click on the on the contact, so it is sending a random to the set is it is sending a message by randomly, and when this message is received at potential user to the potential users, some of the potential users will come to the user state, which is shown by this transition, which is the word of mouth. And this transition is triggered by the message by, and this transition is basically guarded by, because we by adoption fraction. That means not all the potential users which receive this message will come to the user state. It's about 1% of the potential users, they will come to the user state. So that's all for this phase. Now if I just save it, and before saving there is there's an asterisk on the top of 5. Now it's gone, so this shows that it's saved now. So let's run this model and see how our simulation looks now. Okay, there's one thing I have to close it now. I told you earlier as well that when we copy something here in the agent diagram, it also gets copied on the main diagram. So I will just delete it from the consumer diagram so it does not get duplicated here. Now you can see again there is a asterisk near 5, so I have to save it. So it's gone. Now run it, and when you run it you will see the simulation. Okay, so just run it. So I can run it at the as far I can run it as fast as possible. So now it's in the virtual mode. Now you can see how the potential users are becoming users now when they come across two things. One was the advertisement that had some ad effectiveness. Now we have also added the effect of the word of mouth. So this is how this simulation now how this is how the market is behaving. Okay, it's done now. So just to give you an idea that what word of mouth what is the effect of the word of mouth, I'll just go to, we have already seen these steps. So now you can see here that what happens that when there was advertisement but no word of mouth, and now we have added word of mouth plus the advertisement. So you can see the market saturation. So how quickly the market is saturating now. Before it was taking some time, but it's this saturation is now uh, it is it has picked up the speed. So the word of mouth along with the advertisement, it is it is increasing the product adoption. So that's all for part 5. In the next video we will discuss another important aspect, that is the product discard. So what happens when the product life cycle ends? So when this happens, the user falls back to the potential user state. And finally, do not forget to practice along by downloading the AnyLogic. So I will see you in the next part. Stay tuned. Thank you. Like all the products, the water bottle we are discussing in our agent based modeling of the marketing dynamics, it also has some finite life. And that means that after some time, the user discards the water bottle, and a user might think of purchasing a new one. So, in this video, we are going to add product discard to our model. The first thing is the disclaimer about the material of these tutorials and the software that we are using, AnyLogic PLE. So let's suppose that the smart water bottle, it has a life of 6 months. So what happens after 6 months? That the user discards the smart water bottle and the user returns back to the potential user state. And when the user is in the potential user state, the potential user might or might not buy that product. So for the time being, we consider that when the product gets discarded, the user reverts to the potential user state. So uh, we will add another parameter here. We will call it discard time, and this parameter has the it's of the type time. It has units, months, and it has a fixed value of 6 months. And then we will draw a transition from the user to the potential user, and this transition will be a timeout type of transition. We will call it discard, and the timeout will be the discard time that we have just defined earlier. So this is how we can add the product discard. So let's switch to the AnyLogic and see how it's actually done. So this is our AnyLogic, and I have already copied the steps that we just discussed, and let's implement them. So just a brief recap. If you see at the if you have a look at the on the left hand side, this is the our project. This is basically phase 6. It has a main diagram, which is open right now, and it also has a consumer diagram which we can open it by double clicking on the consumer icon. So this is the consumer diagram in which we have already made some state chart and we have already defined some parameters in it. So for the sake of convenience, I'll copy these steps and copy these steps in the consumer diagram. So the first thing is we have to add a parameter here. Now I want to emphasize one thing here, because we are doing agent based modeling. So that's why we are defining this parameter discard time in the consumer diagram. We can also define it in the main diagram, but right now we are just following the paradigm of agent based modeling. We are defining it in the consumer diagram. Otherwise you have to remember that this is a global variable, rather global parameter, and it is used by all the agents. So we could have defined it in the main diagram as well, but for right now we are defining it in the consumer diagram. So go to the palette. In the palette there is an agent library, and if you click on the agent library, you will find the option of adding a parameter. Select this parameter and drag it on the canvas. So, and on the right hand side you will see the properties of this parameter. So we will call it discard time, and it is of type time, and the units are the months, and let's give it a default value of 6. So this is step 1, easy. Now let's add a transition, and as I discussed earlier, what happens when a user uh, discards the product, the user returns back to the potential user state. So for that, go to the state charts, and here there is a transition library, sorry, transition option. So I discussed in my previous videos as well that if you hover your mouse on these icons, then you will see the number of name of the libraries which are available to you. So go to the state chart library, and there is option of transition. So if you double click it, a pencil icon will appear here, and using this, click on the contact, click on the user box, and then from here move towards the potential user box, and this clock shows that this is the basically right now. If I, because this transition is selected, so if you look at the right hand side, there is the properties of this transition. We will call it as discard, and it is, this transition is right now triggered by timeout, and we discussed in a previous video that transition can also be triggered by a message, but right now we are using a time based transition, so we will use the trigger of timeout, and the timeout will be the, here, type in the value of the, type in the name of the parameter you just defined, discard time, and it has a unit of days, sorry, months. So that's all. uh, Click on the show name as well, so you can see here. So you have now, by using these two simple steps, you have added a transition that is showing the product discard, and after the product discard the user is going back to a potential user state. So let's save our model and run the simulation. Okay, before running, uh, I discussed it in the last video as well. So whatever we copy here in the consumer, it also gets copied in the main. So you can see there are like two uh, two screenshots of the steps. So because we are done with it in the consumer diagram, so I'll just delete it, and now I'll go and run this thing. And before that, let's save it and run the simulation. So this is our simulation running at the normal speed, real time speed. We can increase it, and I'll just shift to the virtual mode. So let's click this button, and you can see how the potential users are converting to the users and how the users are increasing. Previously we didn't have the discard, so this curve, it kept on rising, but right now after reaching a certain value, after, let's say, after the passing of the 6 months, the potential, the users will discard the product, and they will return back to the, they will start returning back to the potential user state, and from that state they can come back to the user state. So that's our simulation. Now we have successfully added the word of mouth, and we have also added the advertisements, and now we have also added the product discard time. So what is the effect of this thing on our simulation? So if you look at the slide, on the top is the figure on the of the, it's a graph of the market saturation when we just had word of mouth and advertisement, and below this graph it shows how the product discard affect the product adoption curve. So that's all for the, for this video. In the next video we will add product delivery time. So thanks for watching. I'll see you in the next part, and stay tuned. So far we have assumed that our product is readily available. That's why the consumers, they were moving directly from the potential user state to the user state. And in this video we are going to make our model more realistic, and we are going to add uh, another state between the potential user and the user state, and this state would reflect the effect of delivery time in our model. So the first thing is the disclaimer about the software and the material. So we are going to add product delivery time. So our model so far has assumed the product is readily available. Now we are going to make it more realistic, and for this we are going to add another state, and we will name this state as wants to buy state. Now this state, basically, it will be between the potential user and the user state. So we had initially had we had these two states. So what will happen that when the potential user, when they will see ads and through the word of mouth, they will decide to purchase the product. So when they will decide to purchase the product, they will add in this state, that is wants to buy. So once they are in this wants to buy state, what will happen, they will buy the product, and they will purchase it. And let's say the purchasing will be a time of decision, that means this transition will be triggered by the time. So let's now keep the time to get the product is 2 days. So after 2 days they will shift from the wants to buy to the user state. And the after, let's say, 6 months, when the product life finishes, the user will go back to the want to buy state. So in this way we can add some more realism to our market simulation model. So let me just clear it. So for doing this, we already have two states, potential user and the user state. So the steps for doing this are, I'm going to show you the steps. We will make some space between the potential user and the user state. We will disconnect the transitions. We will add another state, want to buy, and then we will, as done before, we will add some entry action. What happens when the consumers enter from the potential user to user state, we will add a entry action, and then we'll add a transition from wants to buy to user state, and we'll call it purchase, and it will be triggered by timeout. So, and then we'll also add some statistics to in the consumer, and then we will display them in the graph. So let's see how this thing is done in AnyLogic. I'll switch to the AnyLogic view. So I've already opened the market phase 7 model here, and uh, part in this video we are going to add delivery time. So I'll just copy these instructions and I'll open the consumer diagram here. This is the diagram that we made in our last videos, couple of videos. So I'll just copy them here, instructions. So the instruction says that make way between, make a gap between the, make space between the potential user and the user. So we already have some space here. Let's say we just move it more, let's say, okay, and then disconnect the transitions. So I'll just disconnect them. So you have to notice one thing here, that when we disconnect a transition from a state, the arrows, they turn red. These red arrows show that these transitions are not proper. Now I'll also disconnect this transition, and right now let's put it like this, just for the beautification purposes, just trying. Okay, now go to the palette, and then you have the state chart library shown by this yellow box here. Drag the state and drag it here. So I'm going to drag it here, just make it a little big. And one thing more, you can see that I've joined it with these two transitions, and I will also join the disconnected discard transition to here. So going back to the steps, make a space between the potential user, already done. disconnect the transitions already done, add another state, name it wants to buy. So click on this state, and on the right hand side are the properties. Name it as wants to buy, and then show name, the default color is gold. And again we will add an entry action here. The purpose is to identify the different agents that are going through in our simulation, from the potential user to now wants to buy and now to the user. So we will use the shape body function, that is shape body dot set fill color, and the color is gold. So done. So if I press build model now, so it will give me the error. Why? Because it is saying that user cannot be resolved and the element is not reachable. So like, because the states are not connected, so that's why it's giving us the error. Now we will add another transition from the wants to buy to the user state, and this transition we will call it as purchase, and we will show its name, and it is triggered by the timeout, and the timeout is the 2 days. That means it will take 2 days for the custom consumers who are in a want to buy state to get the product and move towards the wants to buy state. So let's check it again. So you see the model is built successfully. Now we don't have any errors. So we have modified the state chart. So our state chart work is done. Now go back to the main menu, and here we will add, okay, now because discussed it repeatedly, we need to delete these pictures from the consumer diagram. So we go back to the main. Now it says the last step number 6, add the statistics. So we will select this consumer diagram in the main, and on the right hand side we will see the properties. So here these are the statistics to the already add to the consumer. We will add another statistic, so I'll just duplicate it. Now I have another statistic here. So n potential and n user were the statistics that we added in our previous video. So we are going to add here another static, and that static is n want to buy. That is the number of consumers who want to buy the product, and this is a count function, and we are going to count it by the agent dot in state, that is the agents that are in state, and these are the consumer population. And here we will add here not potential user, rather the state we just defined, and that state is wants to buy. Press F7, and you see that there are no errors here. So we have added a statistic to consumer. Now click on the chart. This is our chart. So if you click on the chart, and you can add here another data to be displayed on the chart. So press plus sign here. So this data is basically we want to display here the people who want to buy. Okay, so we are going to add let's call it just want to buy. So I'll just copy it from the chart and from the data item above, and I'll paste the here. And what we are counting, what we are displaying, consumers dot, and we just defined a statistic and want to buy. So just remember the fine details here. The state was wants to buy. If you can see in the consumer diagram, the statistic we defined here was n number want to buy, So that's why in the chart we are adding here the title. It makes no difference, you can write it in any way what pleases you. The value, it is coming from consumers dot and want to buy, and we are keeping the color of gold that we uh, chose for the state. So I'll just move this data item to second number. So at the top we have users, and then we have want to buy, and then we have the potential user. So that's all for the work to be done in the main and the consumer diagram. Let's run the simulation. So this is our simulation. So just run it in the fastest speed possible, and you can see now alongside this greenish user curve a yellowish line is appearing, which is showing the consumers who are in the want to buy state. So this graph is different as compared to the graph that we obtained earlier. So now our simulation is getting realistic step by step. We started with the advertisements and then added word of mouth, that the we added the product delivery we have just added here, and in the last video we added the product discard. So this is the complete simulation. So let's see what is the effect of this thing in our market saturation. So you can see this was the only word of mouth product discard and advertisement. Here we have added another thing, that is the delivery time. So this is our graph. So that's all for this lecture. In this part we discussed how the delivery time can be added to the model. Now another very important aspect is the consumer impatience. That is, if the delivery time it gets more than the expected time, the consumer might get impatient, and then they might drop the idea of purchasing the product. So we'll discuss this aspect in the next video. Till then, stay tuned. Bye. In order to make our model more realistic, we are going to add now the waiting amount of time that the consumers are willing to wait for the product delivery. And let's say if this time exceeds the customer's expectation, the customer might just drop the idea of purchasing the product, and they might return back to the potential a potential user state. So this is part 8 of agent based modeling, and we are going to model consumer impatience in this video. So first thing is the disclaimer, and about the software and the material and the material which is used in the preparation of these tutorials. So we are going to model consumer impatience, and as mentioned earlier, if the delivery time it exceeds the consumer's expectation, the consumer might go back to the potential user state from wants to buy state. So for that purpose, we will define two parameters in the main, and that would be the maximum delivery time. We will take the value of, let's say, a baseline value of 25 days, and then we are going to adjust it later on. And then another parameter, maximum waiting time, and it would be 7 days. It would be a default value of 7 days, and then we are going to assume that the product is delivered between something around 1 and 25 days with an average of 2. So uh, to uh, to address this thing, to include this type of uh, times, we are going to make the purchase transition that we added in our last video. We are going to make it stochastic, and for making it stochastic we will go to that purchase transition, and then we will add a triangular distribution from the top ribbon. So if you just have a look at the logic, there is this icon which shows it's about adding the distribution, and if you click on it, there are like multiple distributions, probability distributions that are available in AnyLogic. For our purpose, for the purchase transaction, we are going to use a triangular distribution with a minimum value of 1, maximum of 25, and average of 2. And we are going to add this stochastic time in the purchase transition by using this by using this triangular distribution. And here, if you can see, if you see that it's a triangular distribution, with the 1 is the minimum time and the 2 is the average time, and instead of writing the 25, we will write here the maximum delivery time. We will link it to the maximum delivery time that we have earlier defined in the main. So this is a way to write it. The way and why are we doing it? Because later you will see in this tutorial that uh, we will add some interactivity to our model, and for that purpose we will change the delivery time. So instead of hard coding it to 125 and 2, we are just referring it, we are just linking it to the maximum delivery time that has been defined in the main. And similarly, we are going okay, sorry, that's a different thing. And then we are also going to add another transition, and that transition is that when the delivery time it exceeds the consumer's expectation, they will the consumer might go back to the potential user state. And for that, we are going to define a transition, and we will call it can't wait. And that means that if the consumer is not willing to wait, and the consumer will go from wants to buy state to the potential user state, and we are going to define it through a triangular distribution, in but through a different, but in a different form. Previously, here we defined it with the minimum and the maximum, and we have taken mode as the average value, the value that is appearing as the most. We used as 2 days. Now here, for the can't wait transition, we will use a triangular distribution, but instead of using the minimum, max, and mode, max, and the mode or average, we are going to use two things here. One is the maximum time, and then the percentage of and the variability. So here the variability is like, if the maximum waiting time is 25 days, so we will allow a variability of 15%. And there is more steps to this tutorial, so we are moving to the next slide now. So as discussed that earlier, that we are going to add interactivity, and that's why we'll make our maximum waiting time and maximum delivery time as dynamic. And for that, we are going to use the control toolbar. The control in the palettes, there is a control palettes, and from where you can add different buttons to your model. So we are going to add a slider button, and this slider will have a min, max, and min and max value. We are going to adjust the value of our waiting time, and remember that by default we placed maximum waiting time as we placed a value of 7 to the maximum in maximum waiting time, and value of 25 into the maximum delivery time. And we are going to make it more dynamic by adding these sliders. That is, we will move the slider and we will change these values, and then we will assign two sliders. Will drag two sliders and assign one to the maximum waiting time, and the other to the maximum delivery time. And in the slider, we will make the minimum and maximum value of waiting time as from 2 to 15, and delivery time is from 5 to 25. So we will just vary the values between these two, between this minimum and maximum, and we will see, and we'll try to observe what's the effect of these things, of these parameters, on our simulation. And there are let's just finer details, because we want to we will change these values in integer steps. So we'll use a step size of 1, and we can add the labels if we want to add the if we want. So and we will also add the name, and I think, yeah, that's all for the steps. So let's go to the AnyLogic and see how it is actually done. So it might look overwhelming, but these are very simple steps and I'll walk you through them. So I'll go to the AnyLogic, and I've already opened a file here. That is the modeling consumer impatience. Uh, I've already copied the instructions here. So we are already in the main diagram, and it says that in the main diagram we have to add two parameters. So we'll go to the palette, and this is the agent library. By this time I think you have, by practicing, you might be aware that the parameters are available in the agent library. So drag one parameter here and give it a name as max waiting time. Okay, max delivery time first. We'll go step by step. So max delivery time, and it is double, and the default value is 25. So that means that we are giving it a value of 25, but by adding the sliders we can always change it. So right now it's just a baseline value. So maximum delivery time is 25. So we are now going to add another parameter. You can always drag this from here to the canvas. Easy way is to just click on this one and then Control C and then Control V. You by Control C Control V, you have just copied this parameter. Now just change its name. So previously it was maximum delivery time, so we'll call it maximum waiting time, and its default value is 7. So now we have defined two parameters, the maximum delivery time and maximum waiting time. Now it says that now we have to go to the consumer diagram, and I'll just copy these instructions and I'll place them in the consumer diagram. Okay, so here we are now in the consumer diagram. So I'll just put it here. So once we are done with the main and we have defined the two parameters, now what we are going to do, we are going to make purchase time as stochastic. That is the time to get to make the consumer move from wants to buy to the user state. And we earlier fixed it as 2 days. Now we are going to make it as stochastic, something between 1 and 25 with an average of 2 days. So I'll just delete it, and if you look at the top, this is the icon for choosing the probability distribution. So I'll choose the probability distribution, and we will use a triangular distribution with a minimum of 1. And here, like there are, AnyLogic has a wonderful library of the distributions. So we'll choose a triangular. There are like 3 triangular AV, and that is the triangular, and that is third one is triangular truncated. So we are using the triangular, and the minimum value here is 1, maximum is 25, and the mode is 2. So it is kind of a very skewed distribution, but we'll go with it. So we have defined the stochastic behavior. Now instead of just writing here 25, as I mentioned earlier during the PowerPoint slides, we don't want to hard code it. We want to make it more we want to make it more dynamic. So we will write here as main dot max delivery time. Okay, so now instead of writing 25, we have changed it to main dot max delivery time. So whatever the changes we are going to make in that parameter in the main, we will have the effect of those changes in our distributions. So just press F7 or this build model to see. Okay, so it looks fine. So we have done this. Now we are going to add a transition from the wants to buy to the potential user state. That is the this is a transition that this shows that the consumer might go back to the potential user state if the wait time is too high. So I'll go to the palette, and here there is this is the state chart library. Here we have transition. I will double click, and then I will choose that wants to buy, and I'll connect it to the potential user. So now I have defined this transition, and this transition, I'll just show its name. It is can't wait, and it is timeout, and it is again defined by a probability distribution. So we are going to use an average triangular AB, and that has two parameters. One is the average, and the other is the variability. So I'll just take it as it is and then make changes there. Okay, so this is triangular AB10. Now here I will use the main. Again, I don't want to hard code it, so main dot max waiting time, and the variability is 15%. So in this way we have defined these two transitions. Now these two transitions are stochastic, and they have been linked here with the two parameters that we defined earlier in the main. Okay, so okay, now we have added these two transitions, and just for the beautification purpose, so we are done with our consumer diagram, and we'll go back to the main diagram now. Okay, sorry, I have to delete it from here. Now I'll go back to the my main diagram, and you see that we have done these steps. So I'll just move this thing from here to here and make this thing in the view, bring this thing into the view. Okay, now we are going to add some dynamics or some sort of interactivity to our simulation model, and for that purpose we are going to the, if you hover your mouse here, you see there is a, if you just you see that there is a controls library. So there are like different sorts of button here: a button, checkbox, edit box, sliders, combo boxes. I'll use here the sliders. So let's place them here. Okay, place them. Okay, keep it here, keep them here at the moment. So this is the slider, and this is for the max waiting time, and this is we have to max. Okay, just let me see what's wrong here. So we have got this slider here, and okay, sorry, we have the slider here, and now I am going to I'll just drag two sliders here. So okay, so this slider, it is linked to the I'll just link first the maximum waiting time and the minimum value. Just remember again that we assign a value of default value of 7, but right now I'm making it more interactive, and I'm going to vary it from 2 to 15, and I'll use a step of 1 to make it change in the integer values like 2 3 4 5, not 3.5. And I'll just add labels here. So min max, these values are added here, and this is the for the maximum waiting time. So this is our slider, second slider. We are going to link it to the maximum delivery time, and though the default value is 25, it will have its minimum value is 5 and the maximum value is 25. So now we have and then we also add the labels here. So we have now added the two sliders. So, and finally we'll just write the names here, and we will go to the we can add, we can add the labels to it. And if we just go to the presentation, and there is, a text box here. So I'll just write the name here. This was, I think, max uh, wait time. Okay, and if I just select it, and okay, sorry, yeah, and I can make its size to, where is the size here, size option. Okay, I can't see it right now. Where is the size option? I don't know why I can't see the size option here. Maybe I, okay, it was, it was hidden. So the size is, let's make it 14. Okay, so maximum wait time. And I'll just, I can always drag another text box. I'll just copy it and paste it, and I can just change its name. This is maximum delivery time. Okay, so now I have added the interactivity to my simulation model, and just to make sure that these two sliders, they don't interfere with my simulation, I am going to move them into the bottom of my canvas. So here, there we go. Now we have got the, we have done everything. We have now, we will now run our models to see what's happening in it, and just save it. And it's saved now by pressing Ctrl S, or by, just clicking the save button. We will now run it, and let's see how it is behaving. Okay, so this is our simulation model. These are the times. Let's say right now it is 7, and I'll just make the delivery time, okay, I'll try to change it, oh, I'll try to bring it to a, okay, just leave it. Okay, uh it's right now, its maximum delivery time is 25. We can change it. Okay, I'll try again, because no, okay, I'll just run it again. I just wasted some time here. So here we go again. So this is our simulation, and we are going to make it, even if we, choose here the any value which is not integer, it will automatically convert it to the nearest integer, because we have chosen a step size of 1. Okay, just try running at, 7 and this, and I'll just run it on the virtual speed, and you'll see that how the potential users are going first to the wants to buy state, and then they move to the user state if the time is within their tolerance, and if it's not, they'll go back to the potential user state. So this is how we can add, more controls, more realism to our simulation. So this is a graph of our simulation. You can see the agents changing color from blue to yellow to green, and this process will go on for the defined time, and I think we have defined 365 or 500 days. So simulation is finished, so we are done with it, and I'll now wrap up this lecture, and I'll go to the slide. We have already seen it in the in AnyLogic. Now that's all for this part. In the next video, which is the final part, we are going to now run the model with varying parameters, and we'll see how it is done. In the meantime, do not forget to download it from AnyLogic. Download the AnyLogic PLE and keep practicing. I'll see you in the next video. Till then, stay tuned. Bye. Welcome to the last part of agent based modeling of marketing simulation. In this phase, we want to run the model and we want to observe the adoption process under different settings. So in this part, we are going to use the built-in experiments of the AnyLogic, and we will see how the different settings of parameter affect the product adoption process. The disclaimer. So in this phase, which is a phase 9, we are going to run the model with varying parameters. And our objective is to observe the effect of parameters on model. So as I mentioned earlier, that AnyLogic has built-in experiments. And in these experiments, we can enter the model parameters, we can run a simulation, and then we can compare the outputs in the charts. So for that purpose, first we have to store the data, and for that we are going to define we're going to add a data set from the analysis palette in the main, and it is basically it stores two-dimensional xy data of type double. So we will use we want to know number of users at a particular time. Let's say we are analyzing the number of users, so we will have the number of users at a particular time, and the horizontal axis will be the time, and the vertical axis we will have the consumers, and we will use we will obtain the number of these consumers from an already defined function in the statistics. It is consumers and that dot end user. So we defined it in the video when we were dealing with the statistics. So we will take a sample of we will take 500 samples, we will update data automatically, and the recurrence time will be 1. And then we are going to make some changes in the parameters that we defined in our last video, and we are going to change we are going to associate maximum waiting time and maximum delivery time with a slider control, and then we will set the minimum and maximum value as we have done before. So we will make some changes in the value editors of parameters, and we can also change the labels if we want. And then we will use the compare and experiments, which is a built-in AnyLogic experiment, and then we will create a new experiment, and then we will compare runs, and we will add the parameters, and we will display the data in which data which we have already stored in the data set. And then we can we will see how when we run the experiments, how the different settings of the parameters that we are going to change with the slider, how they affect the product adoption process. We are going to run the model for 500 uh, time units, and that's all for the steps. And let's go to the AnyLogic and see how it is actually done. So I've already opened the phase 9, and phase 9, okay, just let me just move it from the window right now and move it here. So the first phase is we have to add a data set, and for that go to the palette menu, a palette tab, and here go to the analysis, and the analysis is this one, and from here you can drag a data set to our main diagram, and we will just place it outside the canvas. We will name it as user ds, that is user dataset. And let's modify the properties of this user dataset. So the name is user dataset, and it will use the time as the horizontal axis, and the vertical axis, that is the number of the users at any particular time. It will come from the consumers, which is the agent population, and we have defined a statistic, that is dot n user bracket, and we will keep 500 samples. For that we will give us, and we will update data automatically, and the recurrence time is already default as 1 day, and we will use as it is. Okay, so now we have defined a data set. Now next thing is the change, make some changes in the defined uh, these maximum waiting time and the maximum delivery time. So I'll click on the maximum waiting time and see that this is the maximum waiting time, and we had this default value of 7 for this maximum waiting time. So what we are going to do, we are going to change its control to the slider, and we will use the same values which we defined for the sliders in our previous video. And we will, and if you remember, the value for the slider was from 2, for the waiting time is 2 and 15. Okay, so we have defined, uh, we have now changed the control of the maximum waiting time to slider from 2 to 15. Similarly, we are going to repeat this step for the maximum delivery time. So default value is 25, and we are going to change its control to slider with a minimum value of 5 as defined in the previous video, and the maximum value is 25. And yes, that's all. So we have now defined the, we have now linked these parameters with these sliders, and they have the same values. Now this maximum waiting time and maximum delivery time has the same minimum and the maximum value as the sliders we have here in the canvas. So we are done with the first part. Now I'll go back and I'll move this slide, because we have done this. And you can also change the labels, by the way, if you want. If you click on it, click here, then you can always change the label if you want. But let just leave it as it is, and go to the second part, and that is the most interesting part, and the, I think, very powerful feature in the AnyLogic is to use the to run an experiment. So we will go to the project menu. Now if you look at here, there are multiple ways of creating a new experiment. If you just right click on this model name, then there is an option of new. So here, new, we want to create an experiment, so we will select an experiment here, and there are different experiments here, like simulation, optimization, parameter variation. We want to do a compare run experiment, so we'll choose compare runs here. So if this option is done, now we will click next, and then there are like two parameters here which have been defined here. So we will define in the main. So we will select these two parameters, or we can select this one and press like this, or we can just press this button, and the both of them, or all the options available, will be moved to the selection. So click next. Now it is, we have the option of charts. How do we want to compare our output? So the type is, if you, it's a drop down menu. So we have a data set, and the we have, and now we have the chart title, and we will call it as the users. And then what is the expression for it? And the expression for it is root dot user ds. Okay, now what we have done is we have defined uh, we have the we have defined the type of the chart. We have defined the chart title, and we have also linked it with that our data set. Sorry, there's an error here. So this is it was capital S, so user.ds. So when I'll press finish here, it will open another tab for the compare runs. Okay, so you see we have another tab here for the compare runs. So I'll just go back and show you what are the remaining steps here. So in the compare run diagram, we have to change the model time to stop at 500. So I'll go back to the compare runs, and here the model time is stop time is 365 because we did it in our in some of our previous video when we were making the chart. So I'll make it as 500. So that is all for the compare runs. So let's go here to the play button, and now we have two options here. The first thing is a simulation and the second is a compare runs. So let's just click the compare runs here, and it will open this window, and just maximize it. And right now we have what we have is the maximum delivery time has been set as 25, and the maximum waiting time it has been set as the 7. Okay, so I'll just play the run the experiment, and it will, you know, it will display what have the product adoption process when the maximum delivery time is 25 days and the maximum waiting time is 7 days. So here you go. Now you see this shows how the how the how the product adoption process behaves when we have maximum delivery time of 25 and the maximum waiting time of 7. So I'll just make a little bit change here, and let's say I now I have now made the delivery time it is 25, and now the waiting time has also been increased to 25. So I just run it again and see how by changing these parameters to these new values, how does this affect our product adoption process. So the experiment is running, and our output will be displayed through a line graph but of different color. So the red one was 25/7, and now for 25/15, so we will have a different curve. So it's taking some time. Okay, so it's now about to finish, and yes. So you see that when we increase the waiting time to 15, the product adoption process, the number of users, it just increased. So the adoption process was much better than the initial red line. So now let's make a change. Now the maximum waiting time is 2 days. That means we are saying that if the if the product doesn't arrive at consumer place for, let's say, after 2 days, they will go back to the potential user state. So let's see how does this parameters fare in our simulation. So as expected in the green line, you can see that it has a very drastic effect on the product adoption. So in this way you can change different you can change the values of these parameters to different settings and see their effect. uh, there is another aspect to all this discussion, and that is the optimization, but we will cover the optimization of the experiment in our different tutorials. So for now, we are done with we are done with the model with the weighting parameters. I have plotted a graph here, so when we are changing different value, when we are assigning different values to delivery time and the wait time, the the product adoption process is following a different curve. Okay, so that's all for our agent based modeling of the market simulation. Now we are going to end this tutorial right here, but in the upcoming video, what we are going to do is we are going to add market competition. That is, we will be having two companies will be having two products, A and B, and we will see how these companies compete with each other for the adoption of this product, of their product. So it will be it's going to be a very interesting, interesting scenario when we'll be having a market competition. But that would be done in the next video. And that would be video because I did these tutorials in like 10, 15, 20 minutes time, to make it easier to digest. But the next video, it will be the next part where marketing competition will be done. It will be, it will be a very intense sort of video. So that's all for this tutorial. Thanks for watching and stay tuned with the channel. Thank you very much.